Hello dear students, welcome to Karna Maths Academy. Today in this video, we are going to discuss some of the important theorems of probability. So in this video, we are going to prove 4 simple theorems of probability which are needed for the students of class 9, 10 and also the higher level of the students. So dear students, this is the second video on probability. In the previous video, already we have discussed about the important terms related to probability. At first we discussed what is a random experiment, then we discussed what is a sample space, then thirdly we discussed about event and the different types of event, and we defined what is the mathematical definition of probability. Dear students, so let us recall once what we have discussed in the first part of the video so that it will be easy for us to prove some of the simple theorems of probability. Dear students, so let us discuss once again. Let's recall once again what are the important terms related to probability. Dear students, we have discussed that the first important term related to probability is random experiment. Without knowing random experiment, we can't understand what is called probability. Dear student, an experiment is said to be a random experiment. An experiment is said to be a random experiment if its outcomes cannot be predicted. That is, the outcomes of a random experiment does not obey any rule. The examples of random experiment are throwing a die. So when we throw a die numbered from 1, 2, 3, 4, 5, 6 on its 6 faces, it is impossible to say which face will appear. So throwing a die is a random experiment because it is impossible to say which face will appear when a die is thrown. Likewise, tossing a coin is also an example of random experiment. When we toss a coin, we cannot say whether head or tail will appear. So dear students, so we know what is a random experiment. An experiment whose outcomes cannot be predicted is called a random experiment. Then in the previous video we discussed what is a sample space. The set of all the possible outcomes, of a random experiment is called sample space. Then we discussed what is an event. Every subset of a sample space is an event. Dear students, then we defined the mathematical definition of probability, which is also known as classical or prior definition of probability. According to the mathematical definition of probability, the probability of an event is defined as the ratio of the number of event to the number of sample space. If E be the event and N be the number of event, then probability of an event E is equal to number of event by the number of sample space. That means PE, probability of event E, is equal to NE by NS. NE by NS. Dear students, now in this video we are going to discuss simple and most important theorems of probability. The first theorem of probability is the probability of impossible event, or we can say null event. The probability of a null event is always equal to 0. Probability of phi is denoted, used for, the symbol phi is used for impossible event. The probability of impossible event, that means probability of phi, is always equal to 0. And the second theorem is the probability of sure event. Dear students, we know that every set is also a subset of itself. So the probability of the sure event is always equal to 1. And the third theorem is the probability of an event always lies between 0 and 1. Dear students, and the fourth theorem of probability is if A and B are any two subsets, such that A is subset of B, then probability of the event A is always less than or equal to the probability of the event B. So dear students, let's now prove the first theorem of probability, which is probability of an impossible event phi is always equal to 0. So let's go to the proof of the first theorem. The first theorem is probability of phi, that means the probability of impossible event, or we can say the probability of a null event is always equal to 0. Solution. So by the definition of probability, we know that by the mathematical definition of probability, we know that probability of an event is equal to the number of event by the number of sample space. That means P is equal to NE by NS. Probability of an event is equal to number of the elements of event by the number of elements of sample space. Therefore, P phi is equal to, that means if phi is an impossible event, then the probability of phi, that means P phi is equal to number of phi, probability of phi is equal to number of phi divided by number of sample space. By the set theory, we know that a null event does not contain any element. So the number of elements in the null set will be equal to 0. So number of elements in the null set is always equal to 0. So n phi, we can put n phi is equal to 0, 0 by ns. When any number is divided, when 0 is divided by any other number, any other finite number, then the quotient is equal to 0. That means 0 divided by ns, we get equals to 0. Dear students, so this we can say that the probability of an impossible event, that means P phi, is equal to 0. Now let's go to the second theorem of probability. The second theorem of probability is probability of sure event is always equal to 1. So let's prove the second theorem of probability. Dear students, the second theorem of probability is the probability of sure event. Sure event is denoted by the capital letter S. Probability of sure event is always equal to 1. Dear students, we know that every set is a subset of itself. So sure event is the event which has the same number of elements as the number of elements of sample space. So if the elements of sample space and the elements of event are equal, then and the elements are same, then the event is called sure event. So let's prove the second theorem. The probability of sure event is always equal to 1. Probability of sure event is always equal to 1. Solution. We know probability of an event E is equal to number of E by number of sample space. Therefore, probability of sure event, let's replace E, the event E, by the event S, which is the sure event. Then we get replacing E by S, because the given event is the sure event. So NE is equal to NS divided by NS. So now NS and NS, they are same, so we can cancel, then we'll get equal to 1. So dear students, we can say that the probability of a sure event, that means PS is always equal to 1. So this is the second theorem of probability. Dear students, now let's go to prove the third theorem of probability. According to the third theorem of probability, the probability of an event always lies between 0 and 1. That means the greatest probability of an event is equal to 1 and the least probability of an event is equal to 0. So we can say that the probability of an event lies between 0 and 1. So dear students, now let's prove the third theorem of probability. The third theorem of probability is the probability of an event E lies between 0 and 1. Dear students, so we are proving all these four theorems by using the mathematical definition of probability. That means probability of an event is equal to the number of event divided by the number of sample space. That means probability of an event is the ratio of number of event to the number of sample space. So we know probability of an event is equal to the number of event to the number of sample space. Number of event to the number of sample space. Dear students, we know that every subset of a sample space is an event. Dear students, we know that every subset of a sample space is an event. So by the definition of an event, we can say that event is subset of sample space. Event is subset of sample space. This implies that if event is subset of sample space, then the number of elements in the event cannot be less than 0 and it cannot be greater than the number of sample space. Dear students, if E be the event, then the number of elements in the event cannot be less than 0 and it cannot be greater than the number of sample space. Because S contains, the sample space contains event. So we can say that from the set theory we can say that number of event is always greater than 0 and it is less than the number of sample space. From the set theory we can say that if E is subset of the sample space S, the number of elements in the event cannot be less than 0 and it cannot be greater than the number of sample space. So from the set theory we can write 0 number of event is less than or equal to number of sample space and number of event is greater than or equal to 0. Dear students, we have to find the probability of event E and we have to prove that it lies between 0 and 1. So let's divide each term by ns, by the number of sample space, so that number of event divided by number of sample space will get probability of an event. So dividing by ns, the number of sample space, to each term, 0 divided by ns, ne divided by ns and ns divided by ns. So dear students, ns and ns, they are equal, so we can cancel each other. 0 divided by something we get 0, and according to the mathematical definition of probability we know that ne by ns is equal to the probability of an event, P. So we can replace ne by ns by P, which is less than or equal to 1. So this is the proof of the third theorem of probability. So according to the third theorem of probability, we can say that the probability of an event always lies between 0 and 1. Dear students, now let's go to the proof of the fourth theorem of probability. According to the fourth theorem of probability, if A and B are any two events, then probability of A will be less than or equal to probability of B if the set A is subset of set B. So if A is subset, if the first event A is subset of the second event B, then the probability of first event A will be less than or equal to the probability of the second event B. That means PA is less than or equal to PB. So let's prove the fourth theorem of probability. The fourth theorem of probability is if A is subset of B. If any two events A and B are given, and if the first set A is subset of B, then probability of A is less than or equal to probability of B. So let's prove this theorem. Dear students, we know that probability of an event E, the probability of an event E is equal to number of event to the number of sample space, number of event divided by the number of sample space. So we are given two events. The first event is A and the second event is B, and we are given that the first event A is subset of the second event B. That means the set B contains the first set. So from the set theory, if A is subset of B, then from the set theory we can say that number of A is less than or equal to number of B. We can say that number of A is less than or equal to number of B. So from set theory we can say that number of A, if A is subset of B, then we can write number of A is less than or equal to number of B. Now dividing both sides by number of sample space, because we need probability of A. So dividing both sides by number of sample space. Then we'll get number of A by number of sample space, which is by the definition number of A divided by number of sample space is the probability of the event A. So we can write PA less than or equal to PB. NA by NS is the probability of A, and NB by NS is the probability of B according to the definition of the probability of an event. So we have got the proof of the fourth theorem, which is if A and B are two events such that the first event A is subset of the second event B, then the probability of the event A is less than or equal to the probability of the event B. So dear students, so in this video we have discussed the four simple theorems of probability. The first theorem is probability of an impossible event is always equal to 0. The second theorem is the probability of sure event is always equal to 1. And the third theorem is if E be any event, then probability of an event always lies between 0 and 1. And the fourth theorem, we have proved that if an event A is less than the other event B, if A is subset of the event B, then probability of A is less than or equal to the probability of B. So dear students, thank you for watching till the end of this video, and in the next video of probability we'll discuss some of the simple problems of probability by using the formula probability of E is equal to NE by NS. So by using the formula, the mathematical definition of probability, we'll solve some of the important questions of probability. So dear students, thanks for watching this video, and if you have not subscribed our channel, YouTube channel Karna Maths Academy, please subscribe it and don't forget to hit the notification bell so that you'll be the first one to get the new videos related to the different topics of mathematics of school level and college level. Thank you once again. Thanks for watching. Bye.